Hello, friends. Welcome back to the online class for Quantitative Aptitude. So, today we are going to see the topic calendar. We don't get much number of questions from calendar to any competitive examinations, but generally, to know the concept, we just wanted to discuss the topic of calendars and clocks. So, today we will be seeing the topic calendar first. So, before we start the calendar concept, let us understand a few basic concepts first. Normally, for a normal week, let us say, for example, if I talk about a week, we generally have 7 days, right? Similarly, if you take a whole 1 year, consider it as a normal year, not a leap year. In this, we have 365 days. If we convert them into weeks, we have 52 weeks we have, and there will be remaining one odd day for a normal year. Similarly, if I consider it as a leap year, in this leap year, we will be having 366 days. So if you convert them into weeks, again, it will be 52 weeks, but additionally, there will be one more odd day. So it becomes two odd days that are available with us. Generally, for a week, we have 7 days. For a 1 year, we have 365 days. If you divide them into weeks, divided by 7 will give you 52 weeks, leaving one odd day. And for a leap year, we have 366 days. On dividing with 7, that is, there will be 52 weeks available and then two odd days available. To solve the questions in a much simplified and simple manner, we have assigned few codes for date, for days and months. So basing on those codes, we will see how to solve the questions in coming ways. Okay, so first let us understand the codes given to the days and months. So here there is a table here. Now in this, there are certain codes given to us. A Sunday is represented by a code as 0, Monday is represented as 1, Tuesday as 2, Wednesday as 3, Thursday as 4, Friday as 5, Saturday 6. So for all the 7 days of a week, starting from Sunday, we have assigned some values starting from 0 to 6. Now, for every month, for months also, we have given codes. So for this, for a January month, we have given code as 0. For a February month, we have given code as 3. For March, again 3. For April, 6. May, 1. For June, it is 4 days. For July, it is 6 days. For August, it is 2 days. For September, it is 5 days. For October, it is 0. For November, it is 3. For for December, it is 5. Now, generally, how do we remember these codes? Remember the codes for first 3 and last 3 as one set. 033 as first set and last 3 digits 035. 033, 035. And remaining things we need to remember. Well, how do we remember? It says 614625. Simple. 033, 614, 625, 035. Okay, the moment you go to an examination center, you can just directly mention, or some on right paper, or the rough paper given to you, you can directly mention it as 033 as first set, the last set as 035. So 6 months we have covered. Between 6 months, it is 614, 625. Likewise, you need to remember those things. So now, with these concepts, how do we solve the questions? But before we solve the question, there is one more thing that you need to understand. They will be, the questions will be like this. They will give you a particular day of a particular month of a particular year, and they ask you to find out what day that particular number falls. For example, some 15th August 1947 will be on what day? Or some 20th October 2012 on what day? Some 2nd of April 2000, what day it falls? Likewise, they'll give you. So to simplify or to quickly solve those questions, we have given code for certain number of years. The year 1600 to 1699, the code given as a 6. For 1700 to 1799, the code given as 4. For 1800 to 1899, 2. For 1900 to 99, it is 0. 2000 to 2099, it is 6. So 64206. These are the codes given. Now, with this information, let us move on to solve the questions. So how do we solve those questions? These things now we will be seeing it. So meanwhile, just remember those codes once again. So the code for the week starting with Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So Sunday being the code as 0, Monday as 1, Tuesday 2, Wednesday 3, Thursday 4, Friday as 5, Saturday as 6. For months, January, February, March, April, May, June, July, August, September, October, November, December. For these months, January to March is coded as 033. For October, November, December, it is 035. In between, April, May, June, coded as 614. July, August, September, coded as 625. So it is 033, 614, 625, 035. Then for the years 1600 to 1699, we have given a code as 6. For 1700 to 1799, the code given as 4. For 1800 to 1899, the code given as 2. For 1900 to 1999, the code given as 0. For 2000 to 2099, the code given as 6. Okay. Now, let us quickly solve the first question. So the question here says, find on what day did 26th January 1947 fall? So to solve this question, we have total 6 steps to follow. By using these 6 steps, we will be able to answer the question quickly. Okay. Whenever there is a problem is given to you like this, some date of some month of some year, and you are asked to calculate what day this particular date will fall. Okay. So what you need to do is first note down the last 2 digits of the year. Last 2 digits of year. What is the last 2 digits of the year? 4 and 7. Next, second one. Divide the year last 2 digits. Divide the data in step 1 by 4. Divide 1 by 4. That means 47 divided by 4. Take the quotient here. What is the quotient? 4 11s are 44 and 3 will be the remainder. So take the quotient here. Take quotient. Instead of remainder, we take the quotient here. Now, the third step says note down or take the date. Take the date. What is the date? 26. Next, take the number of the month or code. Take code of the month. Let us simplify it as take the code of the month. What is the code of the month for January? It is 0. Next, take the code for years. Take code for year. So now what is the year being asked? 1947. For 1900 to 1999, what is the code given? The code given as 0. For 1600 to 1699, the code is 6. For 1700 to 1799, the code as 4. 1800 to 1899, the code as 2. 1900 to 1999, the code as 2. Now here in this case, since it is 1947, it falls under the range of 1900 to 1999. where the code is given it as 0. So we have written the value as 0. Now add all these values. 7 plus 1, 8 plus 6, 14, and then 1 carry here. 4 plus 1, 5 plus 2, 7 plus 1, that is 84. Now divide result of step 5 by 7. That means 84 divided by 7, that becomes 12. So 7 ones are 7 twos are, and the remainder is 0. Okay, so here the remainder is 0. 0 indicates what day in the days column. Sunday represents 0, Monday represents 1, Tuesday 2, and so on and so forth up to Saturday, remember, as 6. So since the remainder is 0, this 0 represents that it is a Sunday. So 26th January 1947 falls under Sunday. I repeat the problem one more time. The moment when you are given a problem like this, find out on what day this particular date of a month of some year falls. Okay, what you need to do is, first, there can be 6 steps to solve the question. So the first step says, take the last 2 digits of an year. So in 1947, the last 2 digits are 4 and 7. Divide this 2 digits in step 1 by 4. So 47 divided by 4, remainder will be 3, quotient will be 11. Take the quotient value here. Remember, quotient, that is 11. Now take the date. What is the date here? 26. Next, take the code of the month. For January to December, we have assigned some code numbers. January, February, and March is coded as 033. October, November, December is coded as 035. Then April to October, 614, 625. So accordingly, the January code is taken as 0. Then take the code of the year. 1600 to 1699, the code as 6. 1700 to 1799, the code as 4. 1800 to 1899, the code as 2. 1900 to 1999, the code as 0. And 2000 to 2099, the code as 6. So we have taken 0 since it is the value 1947 falls under 1900 to 1999 case. Now add all these values. 47 plus 11, 58 plus 26 becomes 84. Now in the last step, divide the result of step 5 by 7. So 84 divided by 7, 7 12s are 84 goes cancelled, and the remainder becomes 0. So based on this remainder, you are going to decide which day that particular date and month falls. So since the remainder is 0, we can conclude that 26th January 1947 falls on a Sunday. Now let us move to the next question to understand the concept much better. Okay, just look at the question once before we move on to the second question. Okay, now let us move to the second question. So what is the second question says? Find on which day did 5th October 2015 falls. Okay, so let us use again the method that we know. So the first step, what is the first step? Take the last 2 digits, that is 15. The second step, divide 15 with 4. Take the quotient. 4 3s are 12. Okay, the quotient is 3. Now third step, what is the third step? Take the date. What is the date? It is 5th of October, so 05. Next, what is the fourth step? Take the month code. For October, November, December, what is the code? 035. So October, again the code is 0. Right guys, what is the next one? Take the code for the year. What is the code for the year? 2000 to 2099. The code is, what is the code? It is 6. So 06. Now we need to add 15 plus 3, 18 plus 5, 23 plus 6, it is 29. So what is the next final sixth step that you need to do? Divide the value of 29 with 7. So what will be the remainder? 4 will be the quotient. What is the remainder? 7 4s are 28, 1. So what is meaning of 1? 1 means it is Monday. So 5th October 2015 falls on a Monday. So on the first step, we noted down the last 2 digits of the year. Then we divided the value of step 1 by 4. We took the quotient, that is 3. Then on the step 3, we have noted down the code. What is the date we have mentioned? The date of the month we have written in step 3. In step 4, we identified the code for the month October as 0. In step 5, we identified the code for the year 2015. So we have identified them. Then on adding, we observed that the value becomes 29. Now divide it by 7. Find the remainder. Based on the remainder, you find out the date. Since the remainder is 1 in this particular case, we say that the value as Monday. Okay. Now, let us move on to the third question. Find the day. Find on which day did 29th February 2012 fall. Okay. Now, any quick idea? Find on which day 29th February 2012 fall. Now, what is the first step? Take the last 2 digits, that is 12. Now the second step, divide 12 by 4. So 4 threes are. So what is the quotient? It is 3. So 0, 3. Now step 3. What is the step 3, sir? Find out the date. The date says 29. Next, find out the code for the month. For the month of February, it is 035. January, February, March, 035. So what is the code? The code is 03 again. Then what is the fifth step? The code for 2012, 2000 to 2099, it is 06. Now add them. 12 plus 3, 15. 15 plus 29, 15 plus 29, 44. 44 plus 3, 47. 47 plus 6, it is 53. Then on step number 6, what we need to do? 53 divided by 7. 7 sevens are 49. So 7 becomes quotient and 4 will be the remainder. But this year 2012, is this a leap year or a normal year? 2012 is a leap year. Normally, on seeing this as the remainder as a 4, we may conclude that it is on Thursday. But here we need to take an extra step. First, we need to find out whether the year given is a leap year or not. The 2012 is a leap year. In such cases, from the value that we received in step number 6, that is the remainder, subtract 1 from it. Here I am writing, for a leap year, we need to subtract. What we need to subtract? How much we need to subtract? Subtract 1 from remainder of step 6. Remainder of step 6. So what is the remainder in our case? 4. So 4 minus 1, that is equal to 3. That means according to the table known to us, the 3 stands for Wednesday. So here it says the 29th February 2012. Normally also you can see 29th February, generally it will be on leap year only. No need to wait for 2012. or in both cases, in any case, sometimes they may ask you 27th February 2012, again on that particular day also, with the reminder that we received at the step number 6, subtract 1. So you need to take one more precaution with all these 6 steps, that whether the year is a leap year or not. This is the only precaution we need to look at. If it is a leap year, subtract 1 from it. If it is a non-leap year, identify whatever is reminder in step number 6, that is as the date. Okay. If it is a leap year, subtract 1 from the value that you received in step number 6. Okay. Now, let us move on to the next question to find out. Now, here is somewhat interesting question. What is that? Find on what dates of May 2002 fall on Monday. Okay. So here, instead of asking for a particular day, they are asking on what dates in the month of May, the year as 2002, Monday falls. So we need to list out all the days where Monday comes in the year 2002 for only May month. Now, what we need to do? Let us take the first step. What is the first step? Take the last 2 digits, that is 0, 2. Then step number 2, divide by 4. In that case, what you get? Quotient as 0. Step number 3. What is step number 3? We need to find out the day. In this case, let us assume if 1 becomes the Monday, because we know generally Sunday as 0, 1 becomes Monday. So we start from the 1st of May as Monday in this case. Then 4th. What is the 4th step? Identify the code for the month. For month of May, what is the code, sir? 033614. So it is 01. 1 is the code. Then step number 5, identify the code for year 2002, 2099. The code is 06. Now add them. 2 plus 1, 3 plus 1, 4 plus 6, it is 10. Divided by 7, that is the 6th step. 10 by 7, what is the remainder? 7 ones are 7. This is the quotient. Remainder is 3. So this 3 is a Wednesday. Okay. If 3 is a Wednesday, then what you will be understanding it? First, second, third, fourth, fifth, and sixth. Likewise, if third is considered as a Wednesday, then what will Wednesday, Thursday, Friday, Saturday, then Monday. So in such case, what you will be doing? What will you be doing? Similarly, if 3 is a Wednesday, then what you will be doing? Any idea? So if 3 stands as a Wednesday, the remainder 3 stays for Wednesday. So if that means if the first day stands for Wednesday, that means if the first day, because we are considering the 1st of May, 1st of May stands for Wednesday, then 2nd of May stands for Thursday, 3rd for Friday, 4th for Saturday, 5th for Sunday. Here the logic is, when a particular date is not given, we understand that what is 1st May 2002. Let us calculate that first. That is the reason why we took the day as 1. We do not know what is the exact day. So we start from 1st May 2002 and we identify what is this 1st of May. Then accordingly we can calculate what days Monday will fall. So for this first day, first step, we have taken the last 2 digits of the year as 02. Step 2, divide by 4. 2 divided by 4, nothing will come, so it becomes 0. Step number 3, the date, note down the date, that is 01. Step number 4, code for the month of May. Step number 5, code for the year, then divide the summation by 7. The remainder is 3, which is a Wednesday. Okay, guys. Then if the 1st of May falls on Wednesday, 2nd, 3rd, 4th, 5th, 6th we have taken. So that means 6th is on Monday. If 6th is on Monday, then 13th is also Monday because 7 days from it. Then 20th will be on Monday. Then 27 will be on Monday. So 6, 3, 20, 27. These are the days which fall on Monday in the month of May in year 2002. Okay. So this is how we will be solving the questions. Okay, guys. Now, let us move on to the next question. Now, see here, there is one more question given to us. If today is Monday, find after 30 days what day will it be. Okay. Now, for example, total 30 days we have taken divided by 7. What is the remainder? Remainder is 2. 7 fours are 28, so 2 will be the remainder. So if this particular day, that means today, if it is a Monday, if you add 2 days to it, it becomes Wednesday. Okay, this becomes Wednesday. Now, if you take 15 multiples, if today is Monday, then if today is Monday, find after 30 days what day will come. That is the question. 30 days means we have 4 weeks and 2 odd days. Now, add these 2 odd days to the current Monday. It becomes Wednesday. So if today is Monday, then Wednesday is coming. So 15 times the loop goes. So it will be after 30th, after 30 days, the 31st day will be again Wednesday. So this is how the problem needs to be done. Next, January 4th, 2016 falls on Monday. What day of the week does 4th January 2017 lies? Normally we can say 2016 as a leap year or not. So leap year means generally it should fall on Tuesday. Since it is a leap year, it is becoming Wednesday. But how do we take it in a general manner? Now, 2016 4th January, if it is a Monday, the whole year is leap year. So add plus 2 odd days to this particular Monday, then it becomes Wednesday. So 4th January 2017 lies on a Wednesday. This is the simple logic. Or normally you can go with the step 1 to 6 and you can solve. That is the general way of solving the question. Okay. This is general method out of guess and out of shortcut methods. Okay. Next. Move on to the next question. Hari celebrated his birthday on Tuesday, 30th September 1997. When he will celebrate the next birthday on same day? That is the question now. Okay. Now, imagine 30th September 1997 is there. So a boy named Hari celebrated his birthday on this particular day. If he would like to celebrate his birthday again on Tuesday, then in which year will it be permissible? Right? So that is the question being asked. Now, so first, how do we solve this? Let us see. 1997, 30th September is already over. So 1998, this is not a leap year. Is it a leap year or not? Is it a leap year or not? 1998, 4 fours are 16, 39, 4 9s are 36, 28, 4 7s are. So 1998 means how many leap days will come? That is 2. Then 99, it will be 1 leap year, sorry, 1 odd day. Then for the year 2000, so for the year 2000, it will be 2 odd days. Then next 2001, for 2001, this is normal year, so it is 1 odd day. For 2002, again it will be 1 odd day. For 2003, it will be 1 odd day. So if you add them, 2 plus 2, 4, 4 plus 3, 4, 1, 2, 3, 4, 4 plus 4, 8. So even 2002, if you calculate, it becomes 7. So 7 means after next, that is in 2003, he will be celebrating his birthday again on Tuesday. Okay. So normally in this particular problem, 30th September 1997 was a Tuesday. So after how many years or in which year will he celebrate his birthday on Tuesday is the question. That means from Tuesday to next Tuesday, how many days it will be? 7 days you need to travel. So that we need to calculate. How we calculate? Basing on the odd number of days. 1998, it is a leap day or leap year or not? Again, 1998, when divided by 4, 4 4s are 16, 39, 4 9s are 36, then 38. 38 means 4 9s are 36. So definitely it is not a leap year, right? So it will be 1, sorry. It will be 1 odd day. For the year 1999, again, normal, it is 1 day. For the year 2000, which is a leap year, so it is 2. 2001, it will be again leap year, 2001 leap year, sorry, not a leap year, so 1 odd day. 2002, normal year, so it is 1 year. Then 2003, it is also a normal year, so 1. Now, if you add them, 2 plus 1, 3 plus 1, 4, 5, 6, 7. So the 7th day exactly falls Tuesday. That is the reason why in 2003, 30th September, Hari will celebrate his birthday again on Tuesday. After Tuesday, 6 days are over, then 7th day will be again Tuesday, right? So every year we calculated the number of odd days. So adding all those odd days, now we have received 2003 30th September. He will again celebrate his birthday on Tuesday. Okay. Now there is another simple concept that we need to understand. Generally, the concept of odd days. That means how many odd days we will get in a leap year or a normal days. That is what we need to understand. Okay. Generally, for every 100 years, if you take for every 100 years, how many leap years, how many non-leap years will exist? That means there will be 76 normal years, there will be 24 which are divided by 4, that means leap years. So for every normal years, there will be 1 odd day, and for every leap year, there will be 2 odd days. So it will be 76, it will be 48. Now, if you add them, 14 and 124. So 124 odd days will be there for every 100 years. If you want to simplify this further, this 124 divided by 7, how many days? 7 ones are 7, 54, 7 sevens are 49. So we have 17 weeks and 5 odd days. So that means we can conclude that in every 100 years, for every 100 years, there will be 17 weeks and 5 odd days. That means we can say that in a 100-year time period, we have 5 odd days. For 200 years, 5 into 2, that means 10. 10 again divided by 7. So 3 odd days, right? Then for every 300 years. That means 5 into 3, that is equal to 15 divided by 7. So 2 weeks gone and then 1 odd day. Then for 400 years, 4 into 5, that is 20 by 7, then means 5 into 400 years. 400 year means 5 into 4, 20. Then 400th year is again a leap year. That means total becomes 20 plus 1, 21 by 7. That is equal to 0 odd days. So we can say that for every 100 years, there will be 5 odd days. For every 200 years, there will be 3 odd days. For every 300 years, there will be 1 odd day. For every 400 years, 0 odd days. Now let us summarize these things again to understand the concept much better. So here, for every 100 days, we found that 5 odd days exist because we have seen how it is calculated. For every 200 years, 2 into 5, that means 10. This 10 odd days can be converted into 1 week, and then this can be converted as 1 week plus 3 odd days. Then for every 300 years, there will be 3 into 5, that is 15. If you convert them, it will be 2 weeks and 1 odd day. Then 400. For a 400 years, 4 into 5, and since it is a leap year, we need to add 1 to this. So 20 plus 1, that is 21. So 21 divided by 7, so it will be 3 weeks and then 0 odd days that are available. Okay. Now, for example, imagine if there is a question like this: what day, the last day of the century cannot be? In such cases, with the logic that we have, for every 100 years, 5 odd days. For every 200 years, we have 3 odd days. For every 300 years, we have 0 odd days. For every 400 years, we have, for every 300 years, there will be 1 odd day, right? So 1 odd day. For every 400, 0 odd days. That means 5 indicates it is a Friday, 3 indicates it is a Wednesday, 1 indicates it is a Monday, 0 indicates it is a Sunday. So for any century, be it 500 or so, any cases, we will be getting only these values. That means Friday, Wednesday, Monday, and Sunday. So what are the values that are not coming? So that means Tuesday is not coming, Thursday is not coming, Thursday, then Saturday is also not coming. So we can say that for any century year, the last day of that particular year will not be having Tuesday, Thursday, Saturday, but it can have any day of Friday, Wednesday, Monday, and Sunday. So this is how we calculate the normal problems based on a calendar. Though this is of very short weightage in the examination, may give 1 question or may not give. So even 0 questions may come. So in such cases, just we need to understand the logic. For that, we are conducting this particular class. Okay, so just go through the class once, which is available in our YouTube channel. So go through the class once and practice the questions as possible. Okay, guys, and take care. All the best. Have a good day. Thank you.